Hello everybody, today in this video we are going to solve some most repeated and important numericals related to the weight of the body on the earth, moon, Jupiter and respective different stars. So let's write first numerical. So we have in very first number the mass of a man is 70 kg. So this is given over here, and calculate the weight on the earth. So you have to calculate the weight on earth and on the moon. Okay, so let's see here. First write solution. So we have given the mass of a man. So write down mass of a man, that is m is given over here 70 kg. Okay, and we have to calculate two things. See here, calculate weight on the earth. So we have to calculate weight on the earth, that is W on earth we have to calculate. Okay, and in second case we have to calculate weight on moon, that is weight on moon. We have to calculate these two values. Okay, so as we know, weight equal to mg. Okay, and this is also weight equal to mg, but we have to, for the moon we have to take the value of g, acceleration due to gravity for the moon. So I take this m, and for the earth we have to take the value of g is acceleration due to gravity for the earth. So I just write here e. So both are the same, so we can easily calculate with mass. So we have given mass is 70, and the value of g, that is acceleration due to gravity of earth, we know the value of acceleration gravity is 9.8 meter per second squared, and the value of g for the moon, the value of g for the moon is 1.63 meter per second square. Okay, so we have to keep in mind these two values. Okay, we have to remember these two values. So the value of g for earth equal to 9.8, but for this the value of g is 1.63. so we have to take mass 70, value of g equal to 1.63. so after calculating we get both the values. So this value becomes 116.9. this is the weight. See here, weight of man on earth equal to 116.9 Newton, but the weight of man on this moon equals to, this value calculate in calculator, you get 186 Newton. So these two are the required weight of a man on the earth, this, and on the moon, this one. Okay, these two are our required answer. So these two are so easy. Now let's move on to the next question. In question number 2 we have the mass of Jupiter. The mass of Jupiter is 1.92 10 to the power 27 kg. Okay, and radius is also given 7.1 10 to the power 7 meter. Okay, what is the Jupiter's acceleration due to gravity? Now we have to also calculate weight of a stone mass 15 kg on surface of Jupiter. So you can see here the mass of a Jupiter is given. Let's try to do some. I just write here the mass of a Jupiter is capital M is 1.92 × 10 to the power 27 kg is given over here, and radius is also given 7.1 10 to the power 7 meter. What is the Jupiter's acceleration due to gravity? We have to calculate the value of g equal to what, and we have already derived the formula of g equal to gm upon r square. Okay, so after putting this value we just get g value 6.67 10 to the power minus 11, value of m equal to 1.9 to 10 to the power 27 upon r value 7.1 10 to the power 7. So after calculating these all value we get directly from calculator 325.39 meter per second. So this is the value of g for this Jupiter. This is the value of acceleration due to gravity of this Jupiter. Okay, and C also, we have also calculated the weight of a stone of a mass 15 kg. So we have given mass of a stone, that is m equal to what, 15 kg. Okay, as we know we have to calculate the weight, so weight W equal to mg, but we have to take g for this Jupiter. Okay, so I just write here g for Jupiter. This is the value of Jupiter, so I write j. So weight equal to mg, the value of m is 15 and the value of g is 25.39. So this value we can directly calculate from the calculator. Okay, so this value becomes 380.85 Newton. Hence weight of a mass of this stone will be 380.85 Newton, which is our required weight. So this much for this question number 2. Now in question number 3 we have what is acceleration? Acceleration due to gravity on Earth surface of Earth when its mass 24 kg and radius 6400 km. Okay, so for this we have to just move to the solution. What is the acceleration due to gravity? We have to calculate the value of g. Okay, g of Earth when its mass is given 6 × 10 to the power 24 kg and radius r equal to 6400 km. But see here, this is in kilometer, but our standard SI unit is meter, so we have to convert this into meter. Okay, so if we multiply by 10 to the power 3, this will be in meter. Now we know the formula of this g equal to gm upon r square. G is the value of acceleration due to gravity, but here in this case this is Earth, so g for Earth. In the previous one this g is for the Jupiter, so we write j, that is Jupiter. This is Earth, so gm upon r square. So the value of g is already also constant, but the mass of Earth is different than this Jupiter, so we have to take this one upon the value of r is also 6400 into 10 to the power 3 r square. So if we put all these value into your calculator, you can directly get the value of a small g, that is acceleration due to gravity of Earth, equal to 9.77 meter per second square. Okay, so you can write here, hence the acceleration due to gravity of Earth on the surface equal to 9.7 or you can write g equal to 9.8 meter per second square as well. Okay, which is our required value of gravity. This is question number 3. Now in question number 4. In question number 4 we have, this is also most important, most previous question. A person can lift a mass of 100 kg on the surface of earth. On the surface of earth, what mass he or she lift on the surface of moon. Okay, so this is our question. So let's write solution over here. Mass of a body given, mass of body on earth, mass of body on earth is given 100 kg. Okay, and acceleration due to gravity of earth is g. Also we already know 9.8 meter per second square. So we know that weight that is W equal to mg. So this is mass of a body, so 100, value of g equal to 9.8, so this value becomes 980 Newton. Okay, so it means a person can lift a weight this 980 Newton. You can write here, the person can lift how much? 980 Newton on the earth surface. But we have to also calculate the what mass he can lift on the moon. Okay, so we know now this is for the earth. Now for moon, this is for moon. Okay, so for moon we know that W equal to mg, but this value g is for the moon, but we know that weight remains same. Okay, weight remains same either in the earth or in moon or Jupiter, wherever you go, because the factor is only changes, that is g. So weight we have already calculated, 980 equal to m, and the value of gm is already known, that is the mass of moon. Gm means the value of g of the moon equal to numbers 1.63. I have already shown you in the previous one. You can see here the value of g for earth equal to 9.8 and for the moon 1.63. So we have to put just this value over here. So if we only take this value divided 1.63, hence we get the value of m equal to, m means mass of object on the moon. So this value becomes 601.23 kg. Hence you can write here, the person can lift 601.23 kg mass on the moon. Okay, so you can solve the problem like this. So these all problems are the most repeated and important question that will be repeatedly asked in your final examination and SCE, so you have to be prepared. Okay, but questions are so easy, you can easily understand and you can easily do in your examination if you see this all the concepts and these all 4 numericals. Okay, and if you have any queries, any comments, then you can comment down below, and if there is any problems regarding this, then you can back the video and you can see. Okay, repeat it. So thank you very much for watching. Thanks for watching. Please do like, share and subscribe the channel. See you in next video.